Hassan's Maths channel. I'm now answering question number 6 from the June 2024 Pure Mathematics P4 exam from the Edexcel International A-Level Exam Board. And this question here is about vectors. And it says, with respect to a fixed origin O, the line L1 is given by this equation R equals I plus 2j plus 5k plus lambda times 8i minus j plus 4k. Now the first thing I'm going to do is I'm going to rewrite this in column vector form. And there's absolutely no problem with you rewriting things in column vector form, as long as if the question requires you to give some sort of vector in the answer, you rewrite it back in this component or IJK form at the end. But I much prefer to use the column vector form. It just makes calculations that much easier and the work, the working out much neater. So I plus 2j plus 5k, 1, 2, 5. I component, j component, k component. Okay, so that part represents the position vector of a point on the line. Okay, plus lambda, which is a scalar parameter, and that is multiplied by 8i, so it's 8 minus j, that's minus 1j, so minus 1 plus 4k, so that's 4 there. 4. So I've now rewritten this vector in this form, which is, called column vector form. So that's a vector equation for line 1. Okay, so basically if you want to picture what's happening here, say here we have the origin, and we can't draw these lines actually because they're 3-dimensional. So just say this is line 1. It's going like this. Okay, this is line 1. And let's say that this is the point. Could be anywhere. The point on the line, 1, 2, 5. So this vector would be 1, 2, 5. Okay, this is the position vector of a point on the line. So that would be the vector 1, 2, 5. That will take you from the origin to the line. And this 8 minus 1, 4 would be basically a vector along the line somewhere. It would be a vector somewhere along this line. Okay, so this would be a vector along the line. Okay, let's say this is 8 minus 1 and 4. Okay, so let me just do something here to make it a bit more clearer. Okay, so, all right, so this vector, 8 minus 1, 4, let's say it's like this, in this direction. So when lambda equals 0, you'll go from O to this point here, 1, 2, 5. That'll be where you are, that position vector of that point. Okay, and then when lambda equals 1, you'd be over there. Okay, it would be, it would be from O to this point and then plus, so you'll be over here. What am I talking about? You'll be over here. Okay, plus 1 lambda. Okay, so you'll have O to this point plus this vector here. When lambda equals 2, you'll go from O to this point and then 2 lambdas along. It's like lambda times this vector. 2 is 2. If the lambda is equal to 2, it'll be 2 times this vector. So twice this vector along. Okay, so that the vector will then be 1, 2, 5, and that will be 16 plus 16 minus 2 and 8, and so on. If lambda equals 3, you'll be over there. If lambda equals 4, you'll be over there. If lambda equals minus 1, you'll be over here. Lambda equals minus 2, you'll be down here somewhere. So that's how we can understand how the vector equation of a line works. So the first part of the vector, okay, this is the position vector of a point on the line. And the second part of the vector, this is the direction of the line, and this is called the scalar parameters. This part is the position vector of a point on the line, and this is the direction of the vector, the direction vector. Okay, so that's how we can understand like the makeup of the equation or the vector equation of a straight line. All right, now it says the point A lies on line 1. Given that O to A, its magnitude is 5 root 10, show that at A, the parameter lambda satisfies this equation. All right, so we know that the point A lies somewhere on line 1. Let's just say the point A lies over there. Okay, we'll probably find out later on where to put it in relation to our drawing, but just say it lies over there. All right, so if it lies on line 1, okay, if the point A lies on line 1, then what we can say is that it's the coordinates of the point A will satisfy the equation of the line. Okay, so of course we don't know the coordinates of A, but what we can do is we can say that the vector from O to A takes us to A. The vector from O to A takes us to A. Right? So this vector from O to A, let's call it X, Y, Z. Okay, the vector that takes us from O to A. In which case the coordinates of the point A would be X, Y, Z in this form. Right? So that's how we get from O to A, let's say. Now, that means that this position vector will be satisfying the equation of the line. That means that when we write down 1, 2, 5 plus lambda times 8 minus 1, 4, that there's going to be a value of lambda that will take us definitely to X, Y, Z. Okay, which is like the position vector of A. Let's call the vector from O to A, let's call it X, Y, Z. That's what we're doing. So we're letting this vector be X, Y, Z. And in that case, this is true. Okay. So we can say that, X, Y, Z lies on the line. That's why this is true. From here, we can derive 3 equations. Okay. 1 plus 8 lambda is equal to X. And 2 minus lambda is equal to Y. And 5 plus 4 lambda is equal to Z. Those 3 equations can be derived from this fact. So that's one piece of information that's going to help us. Now, the other piece of information they gave us, was that the magnitude of O to A is 5 root 10. Okay, the magnitude of O to A is 5 root 10. So how's that going to help us? Well, we know that the magnitude of a vector, if you want to find the magnitude of, so now this is part 2. This is the second piece of information. Okay, and I'm going to just mark it like that. So now, the magnitude of O to A is equal to 5 root 10. How is that going to help us? Well, the magnitude of O to A is going to be basically X squared plus Y squared plus Z squared. That's how you find the magnitude of a vector, and you find its square root. And that's going to equal, so like the square root of this is going to be 5 root 10 basically. Now, what we can do is we can get rid of the square root. We don't really need that. So we can square both sides. This will be X squared plus Y squared plus Z squared is equal to 25 times 10, which is 250. So X squared plus Y squared plus Z squared is equal to 250. So now we have another kind of bit of information. So we have this Okay, and we have this. All right, these two things will help us. If I combine them together, it will give us this, because I can replace the x with 1 plus 8 lambda, the y with 2 minus lambda, and the z with 5 plus 4 lambda. And because they already told us what we should have, it's very important that you show your steps very, very clearly and carefully. So what I'm going to do is I'm going to substitute, instead of x, 1 plus 8 lambda. So I have a 1 plus 8 lambda squared. And instead of y, I'm going to put 2 minus lambda. So 2 minus lambda squared. And instead of z, I'm going to put 5 plus 4 lambda. So 5 plus 4 lambda squared, and that all should equal 250. So hopefully when I expand and simplify all of this, that's what I should get. Okay, so now don't please make the mistake of, very common mistake, when you are expanding brackets, forgetting the middle term, when you're squaring a bracket. So you're going to have 1 squared, which is 1, plus, and you're going to have this times this doubled. Middle term, don't forget the middle term. That's going to be 8 lambda times 2, that's going to be 16 lambda, plus, and 8 lambda all squared is going to be 64 lambda squared. So that's expanded this one, plus 2 squared is 4. 2 times minus lambda doubled is minus 4 lambda, and minus lambda squared is plus lambda squared. Minus lambda all squared is plus lambda squared. Plus 5 squared is 25. 5 times 4 is 20, so it's 20 lambda. Doubled is plus 40 lambda. Plus 4 lambda is, when you square it, gives you 16 lambda squared. And that's equal to 250. So we have here 64 lambda squared plus 1 lambda squared, that's 65 lambda squared. 65 plus 16, that's 75, that's 81 lambda squared. So that's so far so good. I don't need that much space. 81 lambda squared. Okay, that's dealt with the lambda squared. Now the lambdas. We've got 16 minus 4, which is 12. That's 12 lambda. 12 lambda plus 40. 40 plus 12 is 52 lambda. That's plus 52 lambda. And we got 1 plus 4, which is 5. 5 plus 25 is 30. So we have plus 30 is equal to 250. And we need to subtract 250 from both sides. We have 81 lambda squared plus 52 lambda. 30 minus 250 is minus 220 equals 0. And that's exactly what we had to show. Okay, good. That worked out. So there we have the answer to part A. Okay, now for part B. It says, hence, B part 1. Show that one possible position vector of A is minus 15i plus 4j minus 3k. So we have to basically factorize this and find the value of lambda, or values of lambda. Now, this is a bit of a hassle to factorize. We could use our calculator, or we can use a bit of thinking here, because we know the x component is 1 plus 8 lambda. This is the x component, right? The I is like the x part. So if we consider this, we have 1 plus 8 lambda equals x. So that means in this case, 1 plus 8 lambda should equal negative 15. And that will give us a possible value of lambda. For this, that will give us a lambda that gives us this possible position vector. This is going to give you 8 lambda equals negative 16. So lambda equals negative 2. Okay, and will lambda equal negative 2 help us here as well? You have 2 minus 2, which is 4. Good, for the y component is 4, that's j. And negative 2 here, 5 plus 4 times negative 2. That's going to be 5 minus 8 is going to be negative 3. Good, yeah, so that works for all three of them. Okay, so now we can use this to easily factorize our expression here. So we know that the final answer for one of those would be lambda equals minus 2, which means before that it would have been lambda plus 2 equals 0, which means one of the factors was lambda plus 2. And we can now figure out what the other factor would have been quite easily, because we know that to end up with 81 lambda squared, there must be an 81 lambda here. And, you know, there's a negative sign. So this is positive times negative gives you negative. And we know that 2 times 110 will give us minus 120. Okay, so we can just make a quick check. 81 lambda squared minus 110 lambda plus 162 lambda. So 162 lambda minus 110 lambda gives us 52 lambda, which checks with that. And 2 times minus 110 is minus 120, minus 220, sorry. So there we have the other factors. So show that one possible position vector for A is minus 15i plus 4j minus 3k. All right, we have to do that first. But let's also write down the other value of lambda. So lambda, we have 81 lambda, okay, minus 110 equals 0. So lambda is equal to 110 over 81. Now it looks like this is the value that will give us this, as we know already. Okay, so we can, I mean, we've kind of done that already, I suppose, by showing this, but we can now, you know, do it properly. So we know here, this information here, which I'll take. Okay, I'll take this information. I just need that part of it. Okay, so we know now that lambda is equal to negative 2. So we put lambda equals negative 2 in here. We should get our values. So we can say that O to A is equal to x, y, z, which is equal to 1 plus 8 lambda and 2 minus lambda and 5 plus 4 lambda. And as lambda equals negative 2, you'll have 1 plus 8 times negative 2 and 2 minus 2 and 5 plus 4 times negative 2, which gives us, that's going to give you minus 15. That's 1 minus 16, 2 plus 2, which is 4, and 5 minus 8, which is negative 3. So we can say, therefore, O to A, and as I said, we should write it in IJ form in the end, minus 15i plus 4j minus 3k. Okay, so in the end, we write it in the IJK form. All right, and there's the answer to question B, part 1. Okay, then it says, find the other possible position vector for A. So in this case, we have to use lambda equals 110 over 81. Okay, so O to the other possible position of A is going to be basically 1 plus 8 times 100, and so this is part 2 now. 110 over 81, that's not a very nice fraction, is it? And you have 2 minus 110 over 81, and you have 5 plus 4 times 110 over 81. So I'm just going to use a calculator for this. All right, so take the calculator out. Where's it going? It's disappeared. All right, so we have 1 plus 8 times 110 over 81. I don't know why they have to give such an unfriendly fraction. That's 961 over 81. Okay, and then 2 minus 110 over 81. 52 over 81. And then you have 5 plus 4 times 110 over 81. Oops, too many ones. Over 81. And that gives us 845 over 81. 845 over 81. So again, in IJK form, 961 over 81 over 81. I plus 52 over 81. J plus 845 over 81. Okay. So there we have the answer to part 2. Okay, my guess in this type of question is that they would accept the column vector form because it didn't, tell you, like for example here, to give it in a particular form. But it's just generally better to be safe to, in the end, if they gave you things in that form here, to write things in the same form. I have seen places or questions where students have been penalized, but that's specifically when they ask you to give it in this form. So for example here, for part 1, I would definitely put it in this form because they said show that it's this. So that would be much better for you to do. For part 2, I'm sure they would accept this as well. But just to be safe, write it in the form that they gave you the question in the beginning. All right, now, so there's part 2 of this question. Now we're going to go on to part 3, or sorry, that's part B, 1 and 2 done. Now to part C. So it says here the line L2 is parallel to line 1 and passes through O. I'm going to just bring the diagram across. Okay, so now it says, given that O to A is minus 15i plus 4j minus 3k, and that point B lies on L2, where O to B, its magnitude is 4 root 10, find the area of triangle OAB. Okay, so now what I'm going to do here is I'm just going to adjust this diagram a little bit. Now I know that it doesn't really matter what I'm doing here, it doesn't really matter, but I know that I'm going to call this point AY because I know that A is behind the point that we had. Okay, it's minus 2 according to our lambda was minus 2. So let's make this a bit smaller. Okay, let's call this point A. Okay, so the position vector of the point that we got was this. Okay, so this is the position vector of the point. Okay, and we know our x, y, z now is O to A is the vector that they gave us there. Right, so that's the vector O to A, which is minus 15 and 4 and negative 3. That's O to A. Okay, and that's the origin here, and that's the position vector of the point that they gave us on the line. Okay, now, okay, now this is actually the direction vector, and this is the position vector of the point that they gave us on the line. Okay, now it says point B lies on line 2, right? And line 2 is parallel to line 1, and it passes through the origin. All right, so now just point 2 lies on line 1, and it passes through the origin. Okay, so let me just do something to make it a bit clearer. Okay, so I'm just moving this down here a bit, give me a bit more space. So line 2 is such that it is parallel to line 1 and it passes through the origin. So it's the same direction exactly as line 1. Okay. And it passes through the origin. Okay, so this is line 2, parallel, and it passes through the origin. Okay, so it says here, O to B, and point B lies on line 2. So point B lies somewhere on line 2, where O to B is 4 root 10. Okay, so let's say B is over here. Okay, and this length here is 4 root 10. We got to find the area of the triangle OAB. So I'm going to join a line. Okay, I'm going to join a line. Okay. From A to B. Right? It's supposed to be in a different color. What happened there? Do it again. From A to B. And we're looking for this, the area of this triangle over here. The area of this triangle. Let me just highlight it. Okay, so the area of this triangle here. AOB. Okay, so to find the area of a triangle, what we need is we need two things. Okay, in this case, half base times height won't really help us because we're going to have to find the vertical height. So I think the best thing to do here is to use the area of a triangle is a half times AB sine C, where we have two sides and the angle between them. Now I know the magnitude of O to A is already given to us 5 root 10. Okay, so I know that this is 5 root 10. 5 root 10. And I know this is 4 root 10. So if I can find the angle, let's call it theta, the angle between OA and OB. Okay, so let theta be, okay, the angle between OA and OB. If I can find that angle, that will be my theta. So I'll have a half times AB sine of the angle, and it will give me the area. Okay, so how do I find this angle? Well, we know that there's a formula for finding the angle between two vectors when they are placed tail to tail like these are. Okay, and that is that the cosine of the angle between the two vectors is their dot product over the magnitude, or the product of their magnitudes. Okay, so we can say that the vector O to A, which we know is negative 15, 4 and minus 3. Okay, and the vector O to B. All right, now O to B, okay, is the same direction as line 2. Okay, is, or you can say parallel to line 1. Parallel to line 1. So I don't have to have O to B itself. I can have any vector that's parallel to O to B. So therefore, O to B is going to be some constant times 8 minus 1, 4. Because it's parallel to line 1. Okay, it's parallel to line 1. Right, so even though we don't know what O to B is, okay, because it's parallel to this line, those two lines are parallel to each other, therefore we can take its direction vector as 8 minus 1, 4. Okay, so we can just consider the direction of O to B as 8 minus 1, 4. Okay, so there's absolutely, that's fine. So I can say O to A times 8 minus 1, 4. Its dot product, the dot product of those two will give us what we're looking for. Okay, it'll give us, you know, the A dot B. So the A dot B in our formula, A dot B is going to be given by minus 15, 4 and minus 3, dot product with 8 minus 1, 4. And how do you find the dot product? You multiply the I components together, so minus 15 times 8, plus 4 times minus 1, plus minus 3 times 4. So let's put that in here and see what we get. So we have negative 15 times 8, plus 4 times minus 1, which is minus 4. I'll just put minus 4. Plus, you're going to have a minus 12. So you just put minus 12. Okay, so that will give you, that's minus 136, negative 136. That's a dot product. So we can now say that the cosine of theta is equal to negative 136 over the product of the magnitudes. Now we know the magnitude of A is the magnitude of the vector from O to A, which we know is 5 root 10. And now the magnitude of B, and this is where we have got to be careful here, because we used this vector. Okay. All right. So we can't use this 4 root 10 for the magnitude of B, because we use this vector, which is the same direction as it, but we have to use a magnitude of the vector that we use in the dot product. Otherwise, our answer will not be the same. So it's very important for you to take that into account. So I need to find the magnitude of this direction vector, which is 8 squared plus 1 squared plus 4 squared square rooted. And that will give us the square root of 8 squared plus 1 squared plus 4 squared. That gives us 9. Okay, that's an exact value, 9. Okay, so the cosine of theta is the square root of A, which is 5 root 10 times 9. So you're going to basically have 9 times 5 root 10. So you're going to end up with minus 136 over 45 times root 10. Okay, so there's the cosine of theta. Now, the quickest way for us to proceed here is to just find the value of theta by finding the inverse cosine of this. So theta is equal to the inverse cosine of minus 136 over 45 root 10. You can find what the cosine of what theta is, and then we can proceed. So we have shift cosine of negative 136 over 45 times root 10. And that gives us the angle 162.883. Okay, and then we can find the area is a half AB sine C, which is a half times A, which is a magnitude of this line here, which is 5 root 10, times, now for the B, we have to use this magnitude because we're looking at the area of this triangle. So I'm not going to use this magnitude of 9 here, no, because that was just for finding the angle. Because we use this vector as a dot product, we had to use the magnitude of this vector to find the angle. But we need to find the area of this triangle. So I've got this angle now. I need to do a half times AB sine of this angle, theta. Okay, so I've got to do 4 root 10. So half times 5 root 10 times 4 root 10 times the sine of the angle we just found, 162.883. Okay, so we're going to put this in the calculator, get out the answer. So we have this angle already from before. So we're going to have a half times 4 root 10 times 5 root 10 times the sine of the last answer, which was the angle that we got. And that gives us 29.4308, 29.4308. And they want the answer to 1 decimal place. So we write it as 29.4 units squared. Okay, so there's the answer to this question, which is the question number 6 from the June 2024 paper of Edexcel Pure Mathematics P4. You can find other questions from this paper in the playlist that will appear in the top right of the screen at the end of this video. And you'll also find questions dealing with vectors from this syllabus of P4. You'll find questions, a playlist that will be linked over here, and you'll be able to subscribe to the channel if you haven't done so already by clicking on this link. And the video that will be linked at the top here will show you how to use my channel to find things you might be looking for. Thank you for watching and see you soon.